Here, we have a diagram of a simple bipartite graph. The graph has two sets of vertices, the top nodes U, which are U1, U2, and U3, and the bottom nodes W, which are W1, W2, and W3, and the edges connect vertices from top nodes to bottom nodes. The solid lines represent the edges between the nodes of the graph. The dashed lines represent a possible matching within this graph, indicating which vertices are paired together in the matching. So the matching shown here includes the pairs U1 and W2 and U2, W3. This matching is valid because each vertex is incident with at most one edge in the matching. A bipartite graph is a special kind of graph where the set of vertices can be divided into two disjoint sets such that no two vertices within the same set are adjacent. In this simple bipartite graph, graph G consists of V and E, where V is the set of vertices and E is the set of edges. The vertices can be split into two sets, which are U and W, such that every edge connects a vertex in the U to a vertex in W. In this context, a matching M is a subset of edges such that no two edges share a common vertex. In other words, it is a set of paired vertices within constraint that each vertex is paired at most once. So this matching is perfect if every vertex in this graph is included in the matching, and in this matching M, each vertex in U and W is incident with at most one edge from the matching. Let's try to model a scenario by using a bipartite graph. Let's try to identify the nodes. First, we create two distinct sets of nodes in this graph, where one set of nodes represents the candidates C1, C2, C3, and the other set represents the time slots, which is T1, T2, T3, etc. And then we establish the availability edges just based on the availability indicated by the candidates. We add edges between the candidates and the time slots. So an edge between the candidates node and the time slot nodes means the candidate is available at that time. Solid lines indicates all possible interviews based on candidates' availability, and dashed lines represent the maximum matching, which is a way to schedule interviews so that each time slot is used at most once and the maximum number of candidates are interviewed. According to this maximum matching, candidate C1 is scheduled for time slot T2, candidate C2 is scheduled for time slot T3, candidate C3 is scheduled for time slot T4, and candidate C4 is scheduled for time slot T1. We are looking for a matching which is a subset of edges, such that no two edges share a common vertex. This ensures that no candidate is scheduled for more than one time slot, and no time slot has more than one candidate. So this configuration ensures that the maximum number of candidates are interviewed while respecting the constraint that each time slot can only have one candidate. The maximum matching is the largest set of edges such that no two edges share a vertex, which corresponds to scheduling the maximum number of candidates without any overlaps in the time slot. The resulting matching from the algorithm gives us the optimal interview schedule. Each edge in the matching represents the interview slot with a candidate, ensuring that each candidate is interviewed at most once and each time slot is used at most once.